Hello dear students and welcome back to a new lesson. Now we have finished chapter 1. We reach chapter 2 today. First section is about introduction to vectors. Now I need to remind you that in the previous chapter we talked about, briefly of course, about scalar quantities and vector quantities. When we were talking about speed and velocity, we said that speed is a scalar quantity, but velocity, because it has direction and magnitude, we can say it's a vector quantity. Now, this is just a repetition. We have two physical quantities. We have vector quantities and we have scalar quantities. Now, scalar quantity, guys, it is just a magnitude. Let me give you an example. Temperature, for example. If I told you what is the temperature outside, you're going to say it's equal to, let's say, 50 Celsius or 45 Celsius. I never ask, or nobody would ask you, what is the direction? Because it will be meaningless. Temperature doesn't need direction. Or when we are talking about mass, the mass of this pen, okay, let's say is equal to 50 grams. Nobody asks for the direction, okay? Or you have 2 kilograms of, let's say, apple or orange, but nobody asks for the direction. These are scalar quantities, okay? We have mass, temperature, time, distance, speed also, okay? These are scalar quantities. So if I ask you what is a scalar quantity, you say it's a quantity that only has magnitude, okay? Opposite to that, we have vector quantity, which not only magnitude, but it also needs direction. An example of that is velocity, which we talked about. We said that we should have a direction for velocity, okay? Otherwise it becomes speed, because speed is without a direction. Another example of it is force. For example, when you are trying to push an object, of course you need a direction. You cannot just push objects randomly. Okay, for example, let's say you are moving your table to another room. You need direction. Okay, you cannot just push the table randomly and without any directions. Okay, so we need direction and magnitude too. Magnetic field, displacement, torque, these are all examples of vector quantities. These notes, they tell us that how we write them when we are dealing with scalar quantities and vector quantities. It says that scalar quantities are written in italic and bold, and vector quantities, they can be distinguished when you see an arrow on them. Sometimes you see this force, that it has an arrow on it, and this is just to indicate that it's a vector quantity. Okay, these are important notes, but we don't actually care about them when we are dealing with calculations. Okay, it doesn't matter if you just write F like this or you write velocity like this. Okay, nobody would tell you that this is a mistake. Okay, the important part is that you know the direction and the magnitude of the quantity that you're calculating. Okay, we have addition of vectors now, which is really important. Resultant vector is a vector that represents the sum of two or more vectors. Now, a vector basically is a simple arrow like this, okay? This one, for example, okay? Now, in this chapter, we're going to talk about how we add them, okay? This section is not really important. Just one question is really important, this one. What are the two ways or two types of vector addition? We have graphical method, okay? Let me give you an example. A graphical method, it's not that important, but just to show you, which is that when you have the first, let's say vector, here you see, we have the tail and we have the head. We're gonna draw the first vector and then place its tail to the head of the first vector. This is called head to tail method. And then from the tail of the first one, we're gonna draw an arrow to the head of the second one. This becomes the resultant vector, okay? It's not that important. The important part is the component or analytical method, okay, which we will be talking about it right now. So we have section 2 now, vector operations. Okay, before that, I need you to revise the directions. Remember that north, we could also write positive y or upward. Right, we could use positive x or east. Left, we can say negative or we can say west. South, we can say negative or we can say downward, okay? Now these three notes, 1, 2, 3, I'm going to explain them now. They're really, really simple. Okay, if you have two vectors, they have the same direction. We're going to simply add them together. Okay, now let's say this is the first one and this is the second one. This is equal to 3 meters, let's say east, and this is equal to 4 meters east. Notice they have the same directions. Okay, you can also notice something else, that 4 meters, you cannot make it like this. Okay, let's say this is 4 meters. Okay, it's not a good representation of 4 meters. Okay, the length should also be reasonable, the length of the arrow. Okay, now we have 3 meters east and we have 4 meters east. Look at here, guys. It's positive. Okay, east is positive. So basically, just add them together. We're going to say the resultant vector r is equal to 3 plus 4, which is equal to 7 meters. What is the direction? East. Okay, so when you're adding two vectors, you should also write the direction too. So the resultant vector also needs magnitude and direction. Okay, we can also have this. Let's say we have 7 meters, and then we have another vector which is equal to 8 meters. They are both in the same direction, west and west. Okay, so this is going to be what? We're going to simply add them together. Why? Because they're in the same direction. Okay, now look. We're going to say the resultant vector is equal to, it's west. Is it negative or positive? It's negative, so we're going to say negative 7. Careful. Plus, don't forget the plus. It's also west. 8 meters west. Is it negative or positive? Of course it's negative. So negative 8. The result is equal to minus 15 meters. Do you add the direction? No, careful. Why? Because this negative, this one, is the direction. So this is direction. Okay, and this is the magnitude. You can do something else. You can remove that negative, or 15 meters west. That doesn't have any problem, okay? But you cannot have negative and west together. Or I can, for the one that we solved above, I can remove that east and add positive 7 meters. That is also true, okay? Now, let's have a different example this time. Let's say we have a vector. This is equal to 8 meters east. But the second vector is equal to, let's say, 4 meters west. What do we do with these? They have different directions. Let's see how do we do them. So we're going to say resultant vector is equal to 8 meters. Is it positive or negative? Positive. So 8 plus 4 meters. Is it negative or positive? It's positive. It's negative, sorry. Why? Because it's west. Okay, so it's going to be what? Negative 4. Okay, the result is going to be what? 8. Positive multiplied by negative is negative. So negative 4 is equal to what? 4 meters. What's the direction? What is the direction? The direction is the one that is greater. 8 or 4, of course, even a kid would know that it's 8. So the direction of the large one, so east. Okay, compare this like this. Okay, let's say that this is Newton. Okay, let's make this Newton, and this is Newton. Okay, let's say you and your younger brother, your younger sister, you're trying to pull an object, or let's say you have a rope and she's pulling from one head and you are pulling from the other end. Now you are applying a force of 8 Newton to east, and she's applying 4 Newton to west. Of course you are stronger, so when I find the resultant, it's going to be 4 Newton to east towards you. Okay, that is how this is actually. Okay, So just basically daily examples, okay? But we just turned them into vectors. Now, it's not always on the x-axis. It can be on y-axis too. Let's say we have two vectors. This is equal to 7 meters north. And I have another one, which is equal to, then let's make this longer. This is equal to 10 meters south. Now, how do you add them? You're going to say the resultant is equal to 7. North is positive or negative? It's positive, okay? It's positive y. So 7 plus is south, negative or positive? It's downward, so negative. So 10, negative 10. This is going to be equal to what? R is going to be equal to 7 positive multiplied by negative is going to be negative 10. And then this is equal to what? Sorry. Negative 10. This is equal to 7 minus 10 is equal to negative 3 meters. Or we're going to say 3 meters. Which one is larger? This one or this one? Of course 10. So add the direction of the one that is greater. So 10 meters south. Oh, don't change it. It's the same thing. Okay. Now this is when we have what we call vectors that they are parallel. We can say they're like this together. Okay. They can have the same direction or they can have different direction. What if this time, guys? What if this time we have a vector like this? Okay, let's say vector A. And we have another vector. And this is vector B. What do we do now? Do we add these two together? Okay, let's say this is equal to 3 meters. And this is equal to, let's say, 4 meters. Do we add them together? No. They are perpendicular to each other. Careful. They make an angle of 90. Okay, so we don't add them together. The resultant vector, by the way, is from the tail of the first one to the head of the second one, like this. Okay, this is the resultant vector, R. Okay, or we can say C. Okay, we can say C. This is C, the resultant vector. But what is the magnitude of it? You're going to say it's equal to 4 plus 3, which is equal to 7 meters. Incorrect. This is now not how we add them together, because they are perpendicular. Careful, we only said we do this method when they are parallel like this together. Okay? For example, the direction is, the first one is like this and the other one is like this. Or they are both in the same direction. You don't add these two like this, okay? We have a different method, so don't do that mistake of adding them together. This time we are dealing with angles and things like this, okay? Now, the first thing I want you to know is that this C, the resultant vector, makes an angle with the first one. Okay, so this is called theta. And this theta, why is it important? Remember, it's a vector. So we need direction. This angle is basically direction. Now, let me remove all of these. We don't need these. Okay. You have studied this in math, that the vector close to the angle is equal to what? Is equal to, or we can say it's called adjacent. What about this one? Okay. This is called hypotenuse. Okay, and this one, which is opposite to the angle, is called opposite. Okay, now let's give them their names. This is A, this is B, and this was C. Okay, now how can we find the resultant vector? How can we find the magnitude of the resultant vector? Okay, we're gonna use a very famous law, which is called Pythagorean theorem. Okay, this is going to be what we're going to say: c squared is equal to a squared plus b squared. Okay, and for this theta to find, this is for finding the magnitude, but for finding direction, we're going to say what? We're going to say theta is equal to tan theta is equal to opposite divided by what? Divided by adjacent. Okay, or we're going to say delta y divided by delta x. Okay, and then we're going to say tan inverse theta is equal to tan inverse opposite divided by adjacent. Okay, now enough with the talking and with these explanation. Let's solve an example. Okay, so we have sample problem A. Okay, let's revise the notes before that. Determining the magnitude and direction. If the two vectors have the same direction, add them together. The resultant vector is the sum of the two vectors with the same direction. If the two vectors have opposite directions, subtract the small one from the large one, and the direction of the resultant vector is the same as the direction of the large vector. Okay, as you see, we have 2 meters east, we have 5 meters west. Subtract them and you can get 3 meters west, or you can just try the method that I used. Okay, add them together, then add the signs, and then you can get the resultant vector. Now, the third point is that what if the angles are perpendicular to each other? As you see here, this is the first angle and this is the second angle. How are we going to calculate that? We're going to use Pythagorean theorem. Okay, c squared is equal to a squared plus b squared. I know this all sounds ambiguous, but let's solve a question and then it's going to be really easy. An archaeologist climbs the Great Pyramid in Giza, Egypt. The pyramid's height is 136. Let me draw this for you. This one is a bit misleading. So let's say we have a triangle, like it's a pyramid by the way, but we're going to make a triangle. Okay, let's say this is the pyramid. We know that the height of this pyramid is equal to what? Is equal to 136. I can also say delta y. So delta y is equal to 136 meters. Okay, and its width, what is the width here? Its width is equal to 2.3 times 10 to the power of 2. So 2.3. What is this? This is delta x. Okay, so delta x is equal to 2.3 times 10 to the power of 2 meters. Okay, now it says someone is climbing that mountain, an archaeologist. What is the magnitude and the direction of the displacement of the archaeologist after she climbs from the bottom of the pyramid to the top? Okay, now look, let's say somebody is here and they are trying to climb the peak of the pyramid. Look guys, does she or he travel all the width? Look, is she traveling all the width? No, look, it's only half of it. Okay, it's only half of it. Okay, so we're gonna say this one divided by 2. Why? Because she's not traveling all of it, only from the bottom to the top. So this is gonna be 115 meters. So delta x is equal to 115 meters. Okay, now let's find the displacement of the archaeologist. How we can do that? I need to find this. Let me draw this for you, by the way. This is the resultant. This is the width of the delta x, and this is delta y. Okay, this is delta y. Delta y is equal to 136 meters. Delta x is equal to 115 meters, and this is the resultant. Okay, you can give it any name, it doesn't matter, as long as you don't make any mistakes in the calculation. So we're gonna say c squared is equal to delta y squared plus delta x squared. Okay, it doesn't matter, you can say delta x squared or delta y squared, you can just switch their places, it doesn't really matter. C squared is equal to 136 squared plus delta x is equal to what? 115 squared. Okay, so this is equal to what? C squared is equal to, let's calculate this, 136 squared plus 115 squared is equal to 31,721. Okay, but we have this, remove this and add the square root, 31,721. Let's take the square root of this, 31,721. We have 178.1. Okay, meters, of course. Okay, now this is the resultant vector. Okay, this is the resultant vector. Remember, we had the angle here. Okay, this is the angle. I need to find the direction too. This is only the magnitude, guys. You cannot tell me what is the direction. You cannot say it's south, it's north, it's west. No, we need an angle. Okay, now how can I find the angle? The angle is going to be what? We said tan. This is really important. You're going to face that a lot in physics. So tan theta is equal to opposite, which is this, divided by adjacent, which is delta x. So delta y divided by delta x. Okay, so tan theta is equal to, delta y is equal to 136 divided by delta x, which is equal to 115. Let's divide this, 136 divided by 115. We have 1 point, so tan theta is equal to 1.18. Okay, but do we leave it like that? Is it the direction? No, we're gonna take the sine inverse of this. So tan goes to the other side. Theta is equal to tan inverse, okay, of 1.18. Okay, let's take the sine inverse, tan inverse is equal to 1 point. So we have 49. Theta is equal to 49.7. This is the angle, guys. So 49.7. Okay, so we found the direction and we found the magnitude too. That is how we solve or we add two vectors when they are not having the same or different directions but perpendicular to each other. Okay, it's pretty easy. Okay, you just need some practice and a little bit of concentration. In the next video, we're going to be solving practice 2A. Until then, see you in the next video.